All right, let's continue. I hope everything is okay online. I will be in Slack as before. So, let's continue. So we had this requirement and analysis cycle of things that happens. And requirements focus on dynamic stuff, who can do what, rules, behavior, what will happen when this happens. Analysis or domain models focus more on information needs. What do we need to know? How should we structure this knowledge in order for us to fulfill the requirements? An example. So we have a student actor. I hope that you can see this a little bit. He can perform a use case. We call it print schedule. So what do we need to know in our system for a student to print his or her schedule? You are students, so what is important to be able to print a schedule? A schedule. Anything else? Printer. Documents. Anything else? So, okay, let's think like this. In order to know what information to put in this document that we send to the printer, what do we need to know?
Which course?
Exactly. We need to know which course a student attends. Student, course. Probably a multitude of courses. So something like this. I think that this is probably the primary information need for this requirement. We need to know what courses you are attending in order to print your schedule. This one I can agree on. We will talk a little bit more about the schedule as we move along. Printer. I would judge that as something that is how. How do we print this? We use a printer and a printer driver and stuff like that. Technical software stuff. Avoid it in the domain model. Docs. Too generic. Use the requirement to delimit reality. Sure, we can print a lot of documents, but that's not what it's about now. It's about printing a schedule. So I would say that these are not good candidates for our domain model. Right? So how should we think? Well, in the book, he thinks that we should think like a map maker. And I think that makes a lot of sense. We are trying to do a visual map over some problem area. And map makers tend to want to do maps for the real world. So they do not involve imaginary stuff. In our case, it's very easy to add technical stuff to the domain model. Software stuff, solutions to problems that we don't know we have already. Avoid this in the domain model. Focus on what's actually there and what's actually needed. We should, of course, use the existing words. Map makers do not make up new names for cities or areas. We use a student and we use course because that's what is used. You know what a student is, and I know what a course is, and we, the users, know these words. Do not include too much information. Think about complementing the requirements. It's not a carbon copy of the requirements. Visual models are great, but they can also become very cluttered and complicated. Everything is connected to everything else, and there's 1,000 attributes and stuff, and you really don't see the important stuff. Map makers don't add things that do not exist, i.e. model the real world. Do not add software stuff, technical solutions, if that's not what your problem area is actually about. Multiple domains is interesting. Sometimes you have more than one problem area at a time. So mixing two problem areas is often not a good idea. You can compare this to trying to make a map over maybe the type of terrain there is, elevations for mountains. Here is a swamp, stuff like that. Important on in orientation competitions, for example. But it's really hard to also add cities and the size of cities and the number of inhabitants and roads and everything on one map doesn't compute really. So think about stuff. Is it two domains? Should we split this in multiple models? How should these models be the same? How should they not? So, for example, we have this domain of students and courses and scheduling, but we could probably imagine other domains that has something to do with students, but not necessarily with courses and stuff like that. And while student maybe is a common concept in both domains, we should think once and twice about mixing them into one model. Maybe it's better to do two. And the third thing is to use experts. Map makers tend to interview the experts on an area, especially when we don't have satellite pictures and stuff. They had to go to the place that they were supposed to map and probably talk to people. Oh, I know that big rock. It's called the X rock. So the same goes for you. Talk to the users. Talk to the experts. Use any source of information about the problem area. There may be books. There may be other types of documents. There may be old manuals to old systems, for example. A good source of information. Maybe you can get your hands on support material. For example, what questions do users usually have, and stuff like that. And maybe there are existing models. Maybe your company has already worked in this domain. Maybe there is something that you can have as a starting point. Maybe you can buy models from someone else or find good models online. So think like a map maker. To find conceptual classes, when you did this, we clearly found a lot of nouns. Student, course, schedule, document, printer. Nouns, it's a good start. Read text, find nouns, could be good concepts. In the book, he presents a category list, a list of common conceptual classes that you can take a look at. As I said, we can reuse. And the idea is to use some form of brainstorming session. So when you're doing the first workshop in a group, you prepare individually by reading the theory, looking at the lectures, reading the assignment itself, looking at the problem description, looking at the requirements that you are supposed to do for grade number 2, and then you gather and you pour out as many concepts as possible. So I found this and this and this and this and this and this and this, and everyone in the group does this. Hopefully you will end up with a big bunch of possible conceptual classes. And the idea is to not debate during the actual brainstorming, because this step is all about quantity, getting as much as possible out there. The next step, on the other hand, is about removing stuff. Removing stuff that's not that good. And now it becomes more a question of quality and knowing what to model and how to model it. And to do this, the first step is, of course, to find duplicates. Oh, this concept is already, you found student, I found student. Oh, it's student concept. Let's put them together. Sometimes you have name variations for the same stuff. Not always easy to find. Maybe you have one requirement that describes something using one name. You have another requirement that describes the same thing. But since this was from an interview with another user, another name is used. Then maybe more thought needs to go into this, and maybe this duplication will be found a little bit later. You can always think about, is this a noun or what it is that we have from our brainstorming session? Is it a class or is it an attribute in a class? I think the example that I have in the lecture is to think about price. Maybe we have items. Item is a concept. We have price also. So should we consider price to be a concept on its own? Or is it just an attribute of the item class? Is it a simple number, 52? Or is it something more complicated? Rule of thumb is things tend to be more complicated actually than you think. So I would probably lean towards having things as conceptual classes first. And then maybe if standing the test of time, it seems to be just some primitive form of data, then move it into the class as an attribute. For price, for example, we could imagine that, sure, we tend to see price as a number in Swedish crowns, but maybe you need to handle different types of currencies. Then price suddenly becomes something more complicated. Maybe you need to handle price as something that can vary over time. So today the cost is 52, tomorrow it is 53, and we need to remember the old price for some reason. Maybe we need to handle returns or something like that. We don't really want to pay the new higher price back to the customer, but rather the price that they actually paid us. So things tend to be a little bit more complicated, but this is something to think about. Is it a class or is it a primitive attribute in a class? Going back to the example of the student and the course, we have this schedule that is quite interesting. So maybe we should have this. prints. Makes it understandable to some degree, right? The student prints a schedule. We have the information needed to print it. But maybe this is just a report. It's just a report over what's the information that we already have. Should we add it or should we not? Well, it depends. If our model is already quite complicated, I think it would be a good idea to remove it. It's not something that we need to know really that a student has printed his schedule or not. However, if maybe in some requirement there is a rule that says the student can only print 5 schedules for free, and then you must pay some amount of money, then maybe it's more interesting to actually have this and remember this information in some way. So watch out for report classes. Even though the schedule is a physical, real-world entity, it's not entirely obvious if we should have it in the domain model or not. Yes? Ah, okay. It's not that camera. I wrote this prints association there. So we could probably remove the schedule altogether because it's just a report. It shows what you can do in the system, and that is typically already up here in the requirement. We know that the student can print a schedule. We don't need to repeat this information in the domain model also. Description classes, that is something that you can find if you have a class and you have some attribute in this class, but you realize that some of the attributes are actually the same for a lot of these objects. For example, I think the example I use is if we look at a car, you can have attributes like the color and the registration number, typically unique for a car object. We don't really want 2 cars with the same registration number. It's not that good. You can have the chassis number or whatnot. The color is probably also quite unique to a car. But maybe you have other things like the description of the car. You maybe have other types of attributes that are more for like the model of the car. So this car model has a description, it has some attributes that's common to all cars of this model. Then you can break this information out from the car object into a description class. In this case, maybe car model class. So this is something also to think about when doing finding conceptual classes. Is these attributes a description of something? Do we have some unique information per object that we need to separate from these common attributes? Then we can do it with a description class. Actors, from your requirements or use cases, you often find the roles people can have in this system. It is not always that these roles should be added to the domain model. We could, for example, think like this. Maybe we have another actor here also, admin. Student administrator can also print the student's schedule. You can go to the administrator and ask for a schedule, and he or she will print it for you. While we need to know the student and the courses the student attends to be able to print the schedule, we don't really need to know the administrator here. We don't need to add this actor into the domain model. There is no information needed for this requirement to be able to execute. We don't need to know that this particular administrator printed this particular schedule for this particular student. That's not something that is needed. So be a little bit wary about the actors. Is there a clear need of information for the requirements? For the student actor, it is, because we need to know the courses. For the administrator actor, we don't really need to know this, at least not currently. Yeah, as I said before, try to separate domains. Typically, you should be able to show the domain model to an expert in the domain, and they should be able to recognize the words and the association between these concepts. Typically, this is a good test of a domain model. If the domain experts, the end users or whatnot, can understand the model, it is probably a good representation of reality. If you have mixed in, for example, a lot of technical stuff, database shows up, web server shows up in the domain model, and chances are that the domain experts have no clue about these kind of technical details. So be wary. Yes. Next step, when you have a bunch of classes, you need to find relations between them. And again, relations that support the requirements. You can have a starting point by looking at verbs, for example, in the requirement text or in the problem text. But just as with just using all the nouns, we need to remove some. We need to prune this to really find the associations that are important enough to show visually on our in our domain model. Typically, this means that there is some form of, we need to remember this for a period of time. For example, that the student attends a number of courses. It's something that we need to remember to fulfill not just this requirement, but possibly other requirements too. It is not something that just is done and then forgotten about. There is a common association list also in the book, common associations that you can find in domains. Some guidelines: use good names. It's often quite tempting to write has, contains, or consists of as association names. Sometimes that's fine, but try to find the real relation between these two concepts. An example is, we have a person and we have a car and we have an association between them, and if we use just has, we have no idea what it means. A person has a car. Does it mean that he or she drives the car? Do they own the car? Have they owned? All right. Change of battery. So, hopefully it works again. I have some lines that go up at least, so let's continue. So, we need to take some care when adding this multiplicity information also. So, just don't add it everywhere. Add it where it's actually needed and where it actually says something interesting. All right, you can have derived associations and association classes. I think I will leave those for you to look at the previous lecture. Basically, derived associations are about adding associations that can actually be found by going some other path of the domain model. So you can find the information actually is already there, but you want to show that these two concepts belong together. And then you can use a derived association. Association classes is about adding actually a class for each instance of the association itself. Typical example is you have an employer and an employee, and the employee works at the employer. That's the association. But this association is in itself described by a contract. You have when you're supposed to start, how much you're supposed to work, and how much pay you will get. So we can add this information as an association class. We have composition and aggregation, especially when looking at the models online. You tend to find these diamonds. For domain modeling, I don't think you should use them at all. This is also the opinion in the book. They are not really well defined and just add a lot of hassle when doing these models. Instead of drawing a straight line, you kind of like use these diamonds at one of the ends. So you don't need to do that. Avoid them if you can. They can be useful in some very special circumstances during design, especially if you have are geared towards designing to use a language that do not use garbage collection, but you need to manage the memory yourself, then they can be useful. But that's very special nowadays, at least. You can have multiple associations. So there is nothing that says that we cannot have several associations between two conceptual classes. Again, person, car, we can have one association that says drives, one that says owns, one that says rents, and so on and so forth. Don't be scared of adding multiple associations. You can also have reflexive associations, that is associations to other objects of the same type. Typical example is you have a person class. A person can have children that are also persons, and the children can have parents. Right? So, next thing, we have conceptual classes, boxes with names in them, nouns. We have associations, lines between these boxes with names on them, sometimes multiplicity. The next step is to think about attributes. And basically the information and data that is needed to support the requirements. For example, for this course class here, we can probably think of a number of needed attributes like time for the course. We probably, I think, would need to expand this to have some kind of rooms, online stuff. Probably more things are needed here. So attributes and maybe even more conceptual classes that are actually needed. Same thing goes for the student here. We can find probably a good amount of attributes that are needed. First name, last name, telephone number, email, user account, whatnot. Focus on primitive data types. As I said, is it a conceptual class in itself, or is it just something very primitive, a string or a number or something like that? When doing modeling, focus on what is kind of like odd, strange, or advanced. For example, I would not list a myriad of attributes for a student in the domain model itself. It's not really that interesting. We can have a glossary or a data dictionary where we say that, okay, a student has all these attributes of these types. Doing this in a visual way becomes just cluttered. So focus on what is interesting and maybe a little bit odd or strange. If you have good tooling, you can get a lot of help here. Maybe you can have all the attributes in your conceptual classes, but your tool lets you decide if you should see them or not, or which attribute you should see at a particular view over this model. So if you have good tools, that can help. Sometimes we can use so-called data type classes. A good example, I think, is address. Maybe at first we think about address as an attribute in the student. You have the street, and you have the house number, and you have the postal code, and you have the city, and you have the country. But later on you are doing something else that also needs an address. Okay, we have these two in common. Maybe we should break this out into a conceptual class. So we make a conceptual class out of address instead, but then we get a lot of associations because you have a lot of addresses. Maybe the students even have two addresses. You have some kind of a home address, and you have a care of address, and looking at some other domain, maybe your shipment goes to one address and the customer has a second address, and the return address is this, and your address is that, and the invoice address is something else. And this would just create a spider web of associations in our model. Then we can actually use the address as a data type, as a primitive data type instead. Basically, we put the address a little bit to the side of the model, and instead of doing associations from everywhere, we just say address, colon, and the type name, instead of doing associations. But this is the exception. In 99% of the cases, you should use associations with association names and multiplicities. But there are some circumstances where a data type class is a better choice. For example, adding it would just destroy the model. And looking at the type of associations needed, they're not really that interesting. Everyone can more or less understand this, and we don't need to see it visually. Just as with derived associations, we can have derived attributes. And that's attributes that are actually calculated using something else. So we don't actually store this information, but we calculate it on the fly when it's needed. But we want to show that it's there, so that we don't think that we have missed it. All right. One caveat to always think about, especially when doing this in reality, is that things are more complicated when introducing time. And I think most things need some kind of history and time. The example that we had was this price for an item. You probably need to remember the price over time. And this is something that is often overlooked. It's often needed but not asked for. So even the end users tend to forget that they need or want actually some form of history in their systems. So this is always something that you need to ask for. Do we need to remember this for a period of time? How long is that period? Is it more or less indefinite? Is it 1 year, 5 years? Are there any legal stuff that we need to be aware of? Bookkeeping, for example, may need to keep records for a number of years and stuff like that. This makes things more complicated, definitely, but that's what pays your salary. So the final thing I think is we have associations and we have our conceptual classes. Those are kind of like the bread and butter of domain modeling. We have a little bit of attributes, but we can also use this generalization and specialization thinking. That is these is-a hierarchies. Whole-part hierarchies we can model using associations. Is-a hierarchies we can model using generalization and specialization. So basically, in some parts of your domain model, you kind of like use a more general concept, while there is actually none of these exists in reality. So I would like for all of you to go into a store and ask to buy a fruit. You cannot really do that. You can buy an apple or a banana or some grapes or something like that, but you cannot really buy a fruit. So we can reason about our domain using this fruit concept, but in reality, there are no fruits. There are apples and bananas and pears. So the physical objects are kind of like separate from the conceptual object of fruit. And sometimes you want to model this in your domain model also. Maybe you get a lot of special concepts from your domain experts, but you can see that we can form some form of more general concept from these and work with this general concept instead, because it would make it much easier to work with fruit than work with every possible type of fruit that we can think of in the world. So there is a rule called the 100% rule, and that is that all the information and relations of the more general concept should apply to the more special concepts. So we cannot add something up in the general concept that does not apply to some of the more special concepts. I cannot really figure out one with fruit on the top of my head. And basically you should be able to say banana is a kind of fruit. If you cannot say that and it makes sense, then something is probably wonky. The specializations in turn should add something special. So they should add some attribute, some association, or be handled in some way differently to make sense in the domain model. Maybe you can just replace all these special classes with this more generic concept. And as I said, in reality, no abstractions exist. You cannot buy a fruit. You will. It would be really interesting to try. Hi, can I have a piece of fruit, please? But what do you want? A fruit? They will probably throw the apple at you. So, I think that was basically it for domain modeling. This is what you will be doing in workshop number 1. Prepare by reading up on domain modeling. Check these lists that he has in the book. Look at the lectures. Read the requirements. Remember the requirements delimit the real world and maybe the problem description that you have. The problem description is probably larger than the requirements for the passing grade. So don't go overboard. Try to confine yourselves to those requirements that are there. Think about the stuff that we have gone through today, and that's always also in the recorded lectures. Is this a report? Is this an attribute? Is it the concept in itself? What information do we actually need to fulfill the requirement? Should we add this actor? Should we not add it? Do we have some information that we need to remember about this actor? Find good names for the associations. What is it that we actually mean by this association? Add multiplicities if it's interesting. Think about history and time. Yeah, I think you have some work to do. Software architecture is not part of workshop 1. That is right. So workshop number 2 is maybe loosely based on workshop number 1. That is, you will do a member register with boats, but that's more or less the only connection that they have. So this workshop focuses on doing a domain model for this problem area. Questions? Yes? Ja, spelar ingen roll.
Okay. Alltså, vad är det som behövs? Domain requirements, eller sekvensdiagram, eller vad är det?
What you're supposed to hand in?
Ja.
That's stated in the workshop description. And we can take a look at it. Oh, typically I did not have the tab with that one. So, perform an object-oriented analysis using domain modeling based on the problem description and the requirements presented below. These requirements delimit the domain model. Remember that the only thing certain about requirements, blah, blah, blah. Your domain model should only support the following requirements. So, use these requirements, and you find them here. And what you hand in is basically your domain model. So here you have the problem description, you have some actors, some supporting actors, some offstage actors, and then you have the use cases. So for example, register boat. Register boat. So this requirement should be fulfilled by your domain model. But I don't think, for example, this requirement is included. No, not number 7. So think about the requirements that you're actually supposed to have for grade number 2. I think it's the next grade that takes care of a lot of the payment requirements, for example. Right? More questions? Is derived association the same as a qualified association? No, it is not. A qualifier typically adds some constraints on the association. So it adds some, in this circumstance, this association can exist, in others it does not. Derived associations are associations that we add that are really not needed, but we want to add them anyway because they make our model more obvious. We don't really use qualified associations in the course at all, actually. All right, anything else? Okay, thank you. And make sure you book some tutoring if needed. And I will add some more opportunities for next week also.